Writing functions. Our objective is to identify independent and dependent variables, as well as write an equation in function notation and evaluate a function for given input values. Why learn this? You can use a function rule to calculate how much money you will earn for working specific amounts of time. Let's start with some vocabulary. An independent variable is the input of a function. It's that x value that you stick into the function. The dependent variable is the output of a function. It's the result you get. And a function rule is an algebraic expression that defines a function. So in function notation, you're going to have y equals and then your rule. So y equals maybe 4x plus 3. So that's the rule for your dependent variable. Let's start with using a table to write an equation. So we have a table of 1, 2, 3, 4, and then our y values are -2, -1, 0, and 1. So let's start with looking for a pattern. If we look, our x values are increasing by 1 each time. Now let's look at the difference between our x values and our y values. The y value is always 3 less than the x value. So when we write our rule, y is going to equal 3 less than the x value. So y is going to equal 3 less than the x value. Let's look at identifying the independent and dependent variables. So, in the winter, more electricity is used when the temperature goes down, and less is used when the temperature rises. So, our dependent is the amount of electricity, and the independent is the temperature. The amount of electricity depends on the temperature. So, what is being depended upon? So the what is going to be your independent. So basically your amount of electricity depends on whatever you're inputting into your equation for temperature. Try B and C on your own. Now that you've had a chance to try B and C on your own, let's try them together. So the cost of shipping a package is based on its weight. Well, the cost of shipping a package depends on its weight. So therefore, the dependent is the cost and the independent is the weight. Let's look at C. The faster Ron walks, the quicker he gets home. So the time it takes Ron to get home depends on how fast he's walking. So your dependent is time because it depends on the speed in which you're walking, thus making the independent speed. Now let's look at writing functions. So identify the independent and dependent variables. Then write a rule and function notation for each situation. So knowing your dependent and independent variables is going to help you decide which pieces of information go where. So let's look at this first one together. A lawyer's fee is $200 per hour for her services. Therefore, the fee for the lawyer is dependent upon how many hours she's working. So you have your dependent and independent. And now we need to create the rule. So we need to pick a variable. So why don't we just go with H for hours. And let's look at writing the rule now. So the function for the lawyer's fee is f of h. So your y value, essentially. This also means your y value, in case you're wondering, equals $200 per hour. So if you inputted 4 hours, you would input 4 hours and it'd be 200 times 4. And that would give you your output, which is your dependent. Try this next one on your own. The admission fee to a local carnival is $8. Each ride costs $1.50. Now that you've had a chance to try it on your own, let's look at it together. This one's a little bit more tricky than the one we did earlier because it has two sets of values. The admission fee to a local carnival is $8. That's this initial fee. It's just going to be added on to whatever you end up getting. Because for each ride, it costs $1.50. So the number of rides you're going on is going to be is going to create how many or how much money you have to pay. So the total cost depends on the number of rides. And then you have this plus 8 because that's your initial fee. So looking at the rule, you have $1.50 per each ride plus your $8, which is that initial fee. So that's the rule for this situation. You can think of it as an input-output machine. For Tasha's earnings, f of x equals 5x. If you input an x value, the output is 5x. If Tosh wanted to know how much money she would earn by working 6 hours, she could input a 6 for x. So inputs a 6 in for x. And then an output would be 30. So let's look at evaluating functions. So evaluate each function for the given input values. So for f of x equals 5x, find f of x when x equals 6 and when x equals 7.5. So essentially you're going to substitute the values 6 and 7.5 in to the original equation or the rule and then evaluate. So we have f of 6, that's your y value. All this is stating is that x, your 6, is going to be your input value, equals 5 times 6, which gives you 30. And then your second one, you have f of 7.5. So we're inputting a 7.5 in for x. So we have 5 times 7.5, which equals 37.5. Take a moment and try B and C on your own. Now that you've had a chance to try B and C on your own, let's try them together. So we have g of t equals 2.3t plus 10. And t is going to be 2 and negative 5. So we have g of 2 equals 230 times 2 plus 10, which gives you 14.6. And now let's try it when t is the value negative 5. So g of negative 5 equals 2.30 times negative 5 plus 10. And when we do that, we end up with negative 1.5. Alright, now let's look at C. We have h of x equals 1/2 x minus 3, and we want the input values of 12 and negative 8. So let's start with 12. H of 12 equals 1/2 times 12 minus 3. So we end up with 6 minus 3, which is 3. And then we have our next one. So we have h of negative 8 equals 1/2 negative 8 minus 3. Well, half of negative 8 is negative 4. Minus 3 gives you negative 7. So that's how you would evaluate functions. Alright, so now let's look at finding the reasonable domain and range of a function. So Manuel has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. Write a function rule to describe how much money Manuel can collect from selling tickets. Find a reasonable domain and range for the function. So let's start with our rule. So the money collected from ticket sales is $2.50 per ticket, plus the $20 he's already sold. So with that, we have our X value, our tickets, because if he sells no tickets, he'll just be at 20. So, if he sells X more tickets, he will have collected this function's worth. Manuel only has 4 tickets left to sell. So he can only sell either 0, 1, 2, 3, or 4 tickets. He can't sell 15 tickets. So that's already limiting our material down. So therefore, a reasonable domain would be 0, 1, 2, 3, and 4. Now it's time to figure out what the reasonable range would be, your output values. So we're going to need to substitute 0, 1, 2, 3, and 4 into our equation to figure out what the reasonable range would be. So we already discussed that if we inserted 0, that he would just be at $20. So when he inserts 0, he will be at $20. And I'm going to straighten out this line a little bit. There we go. Here we go. Alright, so what if he were to sell 1 ticket? So 1 times 250 plus 20 gives you $22.50. Well, what if he sold 2 tickets? So it would be 2 times 250 plus 20, which gives him $25. And then 3 tickets would be $27.50. And 4 tickets would be $30. So your domain is that top, and your range is your bottom. So therefore, your range is going to be 20, 22.50, 25, 27.50, and 30. And that ends our lesson on writing functions.